Okay, this problem looks familiar. I thought we did this before, but okay. So we're not going to write first term form, right? We're not going to write first term form. We're going to write in explicit form. So A says if it's arithmetic, write the first four terms. So 4, 8. Arithmetic would be we're adding, right? So plus 4, right? Plus 4. So this would be 12 and 16. There's the first four terms. And the equation, right, in explicit. So that would mean to go backwards, we would subtract 4, and the imaginary zeroth term would be 0. So we would get T of n equals 4, which is, the 4 is this, right, the plus 4, the multiplier, or the common difference, 4n, and then plus the zeroth term, plus 0. Right? And normally you wouldn't write plus 0, but since we're putting it in explicit form, I'd say it's okay to leave it. You could not leave it or leave it in this case. And now let's do B. It says if it's geometric, so 4, 8, that means we're multiplying by 2, so we have to keep multiplying by 2. So that would be 16, 32, right? Okay, so now we need that imaginary zeroth term. So we would divide by 2, and it would be 2, right? Would be that imaginary zeroth term. So we get T of n equals the zeroth term, 2, the multiplier, 2, to the n power, right? So if I put a 1 in, I'd get 4, and I put a 2 in, I'd get 8, so that works. So there's the equation. And C says, create another sequence that is neither arithmetic nor geometric and still starts with 4, 8. Okay, this could be anything, right? I mean, 4, 8, 9, 11, right? Anything, right? Because we're not multiplying, we're not adding to get that.